Welcome back. Now, if you remember in the previous video, I said when you're asked to write a rate law, okay, you're not supposed to use the numbers that are in front of the species to call them the order of the species. So while the major objective of this particular video initially is measuring reaction order, the question also calls for what is the overall rate law. So what are we really looking for is rate equals K times, as I said, you write rate laws typically with respect to nitrogen. So you write K times N2 times H2. This is a standard format. Now what goes in the exponent is the scope of the problem. For now, we're going to call it X and Y. Because do you see the words elementary reaction anywhere in the question? The answer is no. So that means you cannot use these numbers as exponent values. Did I make myself clear? Okay, if not, you have to go back, watch the previous video. Now you can continue staying on this video. All right, our job is to figure out this order so we can not only determine the order with respect to each species, we can determine the overall order, but then also complete the rate law. At this point in time, the rate law is not complete, it's incomplete. So how do we go about it? Well, if you see, this problem is experimentally performed and conditions are manipulated to fit our needs, okay? Now, if you're trying to determine the order with respect to N2, okay, because that's X. How do we do this? Well, if you're trying to determine the order with respect to N2, you pick a condition where concentration of H2 is constant. Okay, so these two conditions, so if I call this, say, A, B, C. Well, A, B, C are three separate runs that I have done, means someone else has done. And they kept the hydrogen concentration constant in the first two runs and changed only N2. So if you're trying to find the order with respect to N2, or whatever it is that you're trying to find on the exam, you got to find a run where the other reactant concentration is kept constant. So A and B, okay, that's what I fixed. So because H2 is constant. And what happens to N2? Concentration is doubled, isn't it? 0.1 times 2 will give you 0.2. So concentration is doubled. So write the 2, because it's doubled, and write the X on top of it, because that's what we're trying to solve, equals what happens when you double, this is doubled, right? Concentration is double. What happens to the rate? That's also double, right? Because 4 over 2, well, is 2. So essentially, well, the exponent will be the same, so I cancel out. So essentially, 2 over X equal 2. What do I have to substitute for the value of 1 to get 2 back? This is 2. I have to substitute something here, so I get 2 out of it. So X has to be 1, right? So 2 over 1 equals 2. So the order with respect to X is 1. Now, this is all pure math, okay? So X is equal to 1. Well, we now know this, okay? Let's solve the order with respect to, I'm going to put something here so that, I don't override it. Now we have to find the order with respect to H2, okay? That means we have to find two conditions of N2 where the concentrations are constant. It's A and C, right? That's where N2 is constant, H2 is changing. What have we done? 0.1 and 0.2, right? So we have doubled the concentration of H2 to get 0.2, right? So 2 over Y is what we're trying to solve for H2. And what happens to the rate? It's 8 over 2 is 4, right? So it's 2 over Y equals 4. What do I have to substitute for y so I get 4? Well, you got it. Y equals 2. So 2 over 2 equals 4, right? Now, do you see I'm going to be able to write the rate law, which is rate equals k times n2. Well, it's just you write n2 raised to the power 1, h2 raised to the power 2. Does it make sense? And why I told you you cannot just use the number in front to complete the problem. Now, in this case, n2 turned out to be 1, but you cannot do that just from looking at these numbers. You see, if you had written 3, that's not what the actual order is. So the order with respect to n2 is 1, the order with respect to h2 is 2. Overall order equals 3. Now, let me go through this problem really quick. If you're trying to find the order with respect to n2, you find 2 runs where there's a change. Usually they will only give you 3 rows of data, at the most 4, because you're not doing just this one problem on the exam. You got a lot of other problems to deal with. So we fixed this, okay? We fixed this. When we were trying to find the hydrogen, we fixed this because these two are constant, right? So that's where things is changing. And then if you pick this one, then you compare this rate, and then you pick this one, then you compare this rate. That's all I have done, and that's how I got these. Now I'll give you a trick. This is something you may want to remember. There's a pattern to it, okay? Reaction order, typically these are the units for K, okay? Which is the rate constant, right? This is the rate constant. Okay, they might test you on the exam as they will give you a bunch of rate constant units and ask you which unit corresponds to, or they can give you a giant problem. The problem looks like it will take 4 or 5 hours to solve, but they would have given you the value of rate constant, say k equals 2.5 m minus 1 s minus 1. And they would have given you a lot of distractors. The problem could be ridiculously long. And they ask you to determine, is this reaction first, second, or third order? You do not have to move a muscle or work your muscle in your arm to solve a problem, because there is no need to. If you know the rate constant value, they would have provided the unit. It's this one. M minus 1, S minus 1, so the reaction is second order. What do you see funny about this is, it's always going to be S minus 1. But if it is first order, you'll see no M. If it is second order, is minus 1M. If it's third order, is minus M2, right? You see this? If it is first, means there is 0M. If it is 2, means you have minus 1M. Basically, you subtract 1 minus the reaction order. And 3 means minus 2m. So this is how people test you on standardized exam. Like, I could write you a giant problem with a lot of numbers, a lot of information, and I asked you, is this reaction first, second, or third order? Immediately, people are going to start putting those numbers, trying to calculate for half an hour, and they get nowhere because those numbers they are provided would not be used in such a way to actually solve the problem. So you would end up with crazy numbers and you don't know what to do. Eventually you see you wasted 15-20 minutes of your time, and then you're going to miss out on some other question. So to save yourself all that hassle, you might see the actual problem on the screen. Like, definitely there will be a problem like this on most standardized exam, because this is not just a chemistry problem. This has a lot of real world application. But then the tip under the reaction order could also be another problem, which may seem like it requires considerable amount of time to solve the problem. But to be honest, if you know the unit, you can guess what type of reaction order is. It's the M that's the giveaway. If there's no M, it's first order. If 1M, it's second order. If there's 2M, it's third order. If there's 3M, that's fourth order, and so on. All right, so now that's all I want to say on the reaction order. So stay tuned for, I think there's only a couple more videos on this chemical kinetics, and It already looks like it's overwhelming, but if you just watch the video once or twice, you're going to get it. All right, so stay tuned.